Yeah, I welcome you all for another presentation on Laplace transformation. Right? In our previous presentation, we have seen the basic definition of a Laplace transformation. Okay, we have seen that for any given function, let us say x of t is any given function. Okay, most of the time this x of t is a continuous time function. Then the Laplace transformation means L of t of x of t, right? L of t of x of t is given as this is minus infinity to plus infinite e power minus s into t small t into x of t dt. This we have seen, and this particular integration, the entire thing can be denoted as capital X of s, right? So in the Laplace transformation you need to remember that that is sorry, the time domain here, the time domain function, the time domain is converted to s domain. This you need to remember, the time domain so is converted to s domain, means your x of t is the time domain function or time domain signal. Then we need to transform this x of t to x of s. So in simple you can say that small x of t, right, small x of t will be converted as like this, capital X of small s. This is what the Laplace transformation means, right? X of t is equal to, x of t corresponds to capital X of s. So here small x is converted as capital X and the time t is converted as s domain. This is called as the conversion of time domain to s domain. Right? This is what, if you take the integration minus infinity to plus infinity, then this particular transformation is called as the bilateral Laplace transformation, bilateral, or otherwise this can also be called as two-sided Laplace transformation, two-sided. Whereas if you consider, instead of minus infinite here, if you consider 0 to infinite, right, 0 to infinite, then in this case this particular expression is called as unilateral transformation, or otherwise also called as single sided Laplace transformation, right, single sided Laplace transformation, right. So as we have seen, as we have discussed in our previous presentation, most of the time this Laplace transformation is widely used tool in finding the transfer function of the given control system, or to analyze the signals characteristics in S domain or in frequency domain in our signals and systems, right. So these are the very useful application of this Laplace transformation, right. In this presentation, let us see one more example. So this we can see one example here. Let us say x of t is equal to some exponential function e power a into t, where t is greater than or equal to 0. This is the given function, right? X of t is equal to e power at, where t greater than or equal to 0. So find Laplace transformation. Find Laplace transformation. How? How we can find out the Laplace transformation for this? E power at is nothing but it is an exponential function, right? So I will explain you the solution part of it, right? We know that from the definition of Laplace transformation, you can write like that. We know from the definition of Laplace transformation, L of x of t means that the Laplace transformation of x of t, nothing but x of t, is equal to, what is the definition actually? General definition, integral over minus infinity to plus infinity e power minus s into small t into x of t dt. This we know already, right? This is the expression actually, right? Now, what is your x of t? E power at means your x of t is nothing but e power at. So, what are the limitations? Here, t is greater than equal to 0. This is nothing but you must take the values as 0 to plus infinity. 0 to plus infinity you must take. If the t is given like this, t is greater than 0 is nothing but the t value starts from 0 up to infinite. Therefore, these values you substitute in this integration, right? Then your expression will becomes like this. Like this. So I will write here. Therefore, your expression becomes like this. How? It is Laplace transformation of x of t is equal to, now my value will be like this, 0 to plus infinity e power minus s into t. What is my x of t actually? E power a into t dt. Clear? This is what. So, I have changed the integration from 0 to infinite, and within this interval, this is what my x of t. X of t is equal to e power at, right? This is equal to, further, how you can write? It is 0 to infinite, then e power. So, the bases are same here, exponential only. Two terms are there, e power minus st, e power at. In these, you can take the common as minus t. Take minus t as common. Therefore, what you will get actually? So, here s will come, and here obviously minus a will come into dt. Clear? Therefore, if you multiply again, minus t into s minus s into t minus st, minus into minus plus, therefore, t into a, at or ta, whatever it is. So, you can take minus t as common, e power, let e be same. So, in the powers, in these power, these are the base actually. So, this can be written as like this. If you take minus t as a common in the powers, if you, okay, then you will get like this, and this is equal to, further. So, what is this? You know that what is the formula? Integral of e power x into dx. What is the formula? Integral of e power x is equal to e power x only. So, integral of e power 2x, let us say, integral of e power 2x is nothing but e power 2x by 2. Clear? Like that. Integral of e power 2x. So, integral of e power 2x is e power 2x. Again, for 2x we have to take integral. Then 2 will come, but that comes in denominator. Similarly, so consider this entire e power minus t into s minus a. If you consider the whole, whatever power is there in this, if you consider the same as x, let us say, then e power x is e power x. Therefore, means that what actually integral of e power means whatever is there as it is, it will come, that is e power minus t of s minus a, that will come there by, this is with respect to dt. Therefore, so your t becomes 1 here, then minus is there, minus s minus a, that comes into denominator part. Clear? That comes into denominator part. So, now for this you need to apply your 0 to infinite. Understood? So, the entire whatever is there in the power, that is minus t into s minus a. If you consider everything as x, then it becomes e power x. Therefore, integral of e power x is nothing but e power x only. Means as it is, whatever you have, the same will come. Again, if you say in the x, minus t into s minus a. So, minus t into s minus a to be integrated with respect to dt, then so your t becomes 1, then what remains? Minus s minus a. Minus s minus into s minus a comes in the denominator, right? So, in the next step, how this can be written as, you can write the next step will be like this. So, this implies that everything we are solving for Laplace transformation of x of t only. Okay, you always don't forget that. This is equal to, so see this minus s minus a is there in denominator. Therefore, that you can write like this, minus 1 by s minus a. You can write like this also. So, this whatever the part is there in the denominator, that is minus s minus a, can be taken as like this. Okay, minus 1 by s minus a. Then what is the remaining? E power minus t into s minus a, right? So in this substitute 0 to infinity, because this is constant actually. Wherever t is there, in that t you substitute the limitations. Upper limit as infinite, lower limit as 0. Then this becomes, it is minus 1 by s minus a. Clear? So substitute in place of t as infinity, means e power minus infinity times s minus a, because wherever t is there, there only we have to substitute the limits. So for substituting the upper limit, in place of t substitute the upper limit as infinite, therefore minus will be there as it is. In t place you substitute infinity, then s minus a minus lower limit. Lower limit means minus, wherever t is there substitute 0 into s minus a. So your problem is almost all over. This is equal to minus 1 by s minus a, right? You can put in bracket, don't write like that, or you can, whatever, nothing wrong in that. Okay, then so see here, e power minus infinity into s minus a. Minus infinity means infinity into something infinity. Clear? Infinity into something infinity, it is minus infinity. Then if you multiply with infinity with something, everything becomes infinity, but minus is there, therefore minus infinity. The entire part is minus infinity. E power minus infinity is 0. Remember that. E power minus infinity is, you always remember, e power minus infinity value is 0. Remember that. E power minus infinity is 0. Therefore this part becomes 0. Then what is this? E power 0. 0 into something 0. Okay, e power 0 is something. 0 is multiplied by minus, it does not affect anything. It will be 0 itself. Therefore everything becomes 0 only. Therefore e power minus 0 or plus 0, whatever it is e power 0 only. Therefore e power 0 is 1. Therefore 0 minus 1, how much? It is minus 1. Minus 1 multiplied by this factor. Then what you will get, you know, this is nothing but, your answer is last step actually. The last step. Okay, so obviously you will get, so Laplace transformation of x of t is nothing but Laplace transformation of, what is your x of t? E power a into t, no? This is equal to, now here 0 minus 1 is nothing but minus 1. Minus 1 multiplied by this, minus into minus plus, and obviously we will get 1 by s minus a. This is what your x of s. Put in the bracket. Right? So likewise you have to solve it. Is very simple thing only, right? Clear? Therefore Laplace transformation of e power a t gives rise 1 by s minus a. Therefore the x of t, therefore what you can say, the x of t will be transformed as x of s. Here my x of t is e power a t. If my x of t is e power a t, then your x of s is nothing but 1 by s minus a. That is what the answer. This is what the answer, right? Remember that. So this is what your answer. Okay, means that what actually, then you can write like this, Laplace transform. You can write like this. So if x of t is the given time domain function, my x of t is nothing but time domain function. So with the application of the Laplace transformation, that will becomes as x of s. Means that what you know, so you will get your output in terms of s only. It may be s plus 1 or something, whatever it is. It do mean sometimes fraction will comes, right? Some numerator parameter by some denominator. So in both numerator denominator you will get s, or sometimes you may have the s in numerator itself, depending on the input signal, depending on the x of t. So for this, here my x of t is e power a t. Therefore, exponential function e power at is my function. So for this e power at, if you apply the Laplace transformation, that correspondence as 1 by s minus a, 1 by s minus a. And similarly, I can give you one example for you. Then take minus 80. This is plus 80 actually. Now for your homework or for your practice, I will give you the example. You can try on your own this example. So x of t is equal to e power minus 80. The same you can take t is greater than or equal to 0, no problem. Find Laplace transformation. Find Laplace transformation of this one, this function x of t is equal to t power minus 80. So this is exponentially decreasing function, that is exponentially increasing function. So it will increase, it will decrease, right? So let us try on your own, and in subsequent presentation I will solve this problem for you, right? So with this I will finish today's presentation, and I hope you understood well this, and if you really understood this, and definitely don't forget to give your observation and comments, and definitely you should not forget to share this valuable information with your friends, so that this should reach to every student actually. That's what my intention. So, okay, right, so we'll meet in the next presentation. Till then, yeah, keep on practicing and have a beautiful day.